Hello and welcome to the first lesson of Chapter 6. Chapter 6 focuses on solving systems of equations. There are a variety of methods that we can use, and today we are going to start with probably the most basic one, but it can also be probably the more complex one and probably the least often used one, which is simply by graphing. So, systems of equations, what we are looking for when we are dealing with systems of equations is we're trying to figure out where do the lines for two equations cross. So when the lines intersect at one point, we say there is one solution. When the lines that we graph end up being parallel, we say there is no solution. And when the two lines are the same, we say there are infinitely, I gotta get back my pencil here since I did that. There are infinitely many solutions. And the reason for that is they're the same line. Of course, they cross everywhere. So infinitely many solutions. Now, on your notes packet, this next section, you have a graph that's inputted. And that graph has several lines on it. I count 4 lines. It has 4 lines on it, and each one is labeled with at least one equation. So when we use a graph to determine whether a system has no solution, one solution, or infinitely many solutions, we look at where do those lines cross one another. If the system has one solution, you name it. And what do I mean by name it? Naming it means give the ordered pair. So when we talk about giving an ordered pair, we're talking about the x value and then the y value. Okay? So as you look at your graph that you have, find the line that says y equals negative x. It should be pretty easy to find. It's going to have a negative slope and it's going to cross through 0, 0. Now find the equation that is labeled x plus y equals 3. One thing I know based on thinking about lines is if I were going to rewrite this in slope-intercept form, I would have it become y equals, I'm going to take x away from both sides, so I get a negative x plus 3. And what I see right here is those two lines are going to have the same slope. If they have the same slope, then those two lines are parallel. So this particular set, you should be able to see by looking at your graph, has no solution. All right, now you've got the second problem. So go ahead and look at your graphs and decide where those two cross. So again, I find both of them, and I see that as I look at each one of them, they appear to cross at 1, 2. So these two, when I graph them, would cross at 1, 2. Now, some of you might be tempted to just write the word 1, meaning, oh, one solution, just like for number 1, I wrote no solution. But again, we don't write 1. Anytime there is one solution, we actually write that solution itself, rather than writing the words one solution. All right. Now, this next part says graph the system of equations and then decide, does it have no solution, one solution, or infinitely many solutions? Again, if there's one solution, we name it. Okay, so this first one, I love it. Number 3 is already written in in slope-intercept form. And so I'm just going to graph it based on the information I have. I see that my y-intercept is going to be a positive 4. I see that my slope is a positive 2, so I know that line's going to go up here. But I see right away I can't go up to right 1, so I'm going to go down to left 1. I'm going to plot a couple of points. Once I've got those points, I'm going to go ahead and use a straight edge. For you, it's a ruler. For me, it's this handy dandy tool right here. And I see that I got off a little bit, so I can adjust it. And there we go. So I have graphed the first line. Now, I'm going to go on. I'm going to choose a different color, and I'm going to graph the second line, also in slope-intercept form. So I can see right here the intercept is -1, and the slope is up 1, right 3. It's got a positive slope, or down 1, left 3. And I see right away where they cross. So it's going to be easy for me to write my one solution. But even before I do that, I'm going to go ahead and get that on there. And then I'm going to say, well, where do they cross? They cross at -1, -2, -3, -2. So my answer is -3, -2. So that's the naming it when it has one solution. All right, now when I look at number 4, the first thing I notice is both of these equations that they have given me are in standard form. Now the beautiful thing about standard form is when something is written in standard form, sometimes it's easy just to find the x and the y intercepts. Okay, so that's what I'm going to do. I'm going to imagine that x is 0. If I made x 0, y would be 4. If I made y 0, x would be 4. So there's my x and y intercept. So over 0, up 4, over 4, up 0, and now I draw my line. All right. Now, if that wasn't kind of how you like to see it, if you would rather rewrite it so it looks like it's written in slope-intercept form, that's fine as well. I can move the x, which basically is subtract x from both sides, and it would become y equals -x plus 4. Either way, absolutely fine. All right, so I can do the same thing here for this next one. Kind of whatever is more comfortable to you. You certainly can move the 2x, and it becomes -y equals -2x plus 2. And then we're going to multiply that whole thing by -1 because we don't like the negative on our lone y out here. So it's going to become y equals 2x minus 2. So I can graph it that way. Or I can go back and I can graph it. Okay, I can graph it like I did on the last one where I look at, oh, if I made x 0. So if this was 0, 0 take away what would give me a positive 2? Well, if I made x 0, y would have to be -2. If I made y 0, 2 times what equals 2? 1. So if I make y 0, x would be 1. So 0, -2, 1, 0. And I graph it. All right, I think my blue line is a little bit off as well. Oops. All right, it's a little bit off, but we see it should cross right here at 2, 2. Now you can kind of see the importance of using a ruler and getting yourself some really good lines. Because there may be times when we're asked to graph something that it won't go through a really nice spot. All right, so 2, 2. Okay, It is now your turn, and here is the problem I would like you to solve. You are going to, again, graph the system of equations. Then you're going to decide whether it has no solution, one solution, or infinitely many solutions. If it has one solution, you will write that solution as an ordered pair. Thanks much. Good luck.